Today in geometry, we're going to be focused on the area of regular polygons. So first of all, when you talk about a regular polygon, it's a polygon that has all sides being the same length and all interior angles being the same measurement. So we're going to talk about how to follow that and how to actually use the formula. But the big thing for us in this section is really vocabulary and being able to label stuff. So let's take a look at some of the vocabulary, make sure you understand what it is first. And then we're going to go on to actually look at some formulas. So first of all, this outside shape here would be a hexagon. It's got 6 sides, they're all the same length. The radius is the length from the center of your shape out to a vertex point. Usually they put a letter R on that. The apothem is this little distance that runs from the center and it runs smack dab down the side of your shape. Now you can kind of see that when I go to all the vertex points, I create these little triangles in here. So your apothem is really the length from the center, and it's a perpendicular line, so it's almost like an altitude of this triangle here. Now perimeter would be the distance around the entire shape. So if I know what one of these are and they're all the same, I should be able to very quickly add them up. Now a vertex point is where any of these corners kind of are in a shape. It's where one segment and another come together to kind of form a exchange point. That exchange point right there, meeting point, is my vertex point. Now the big thing in this chapter, or this section, is going to be to follow this area. This area formula is 1/2 the apothem times the perimeter. So just like we did before, you're going to see me take this 1/2 and make it 0.5. But you have to know the apothem, so you have to know this perpendicular distance, and you have to know the perimeter around the shape. Those are going to be what we use. Now, another part that's kind of important in here, sometimes they're going to give you problems that just explain by name what a shape is. So the first few of these, triangle, quadrilateral, pentagon, hexagon, are ones we use pretty regularly. So if you know how many sides it is, you can easily figure that out. There are also some on here, and I would really say these, that don't get used as often. Heptagon is 7-sided. Octagon is 8. I'd say octagon, probably out of that whole group, is one we deal with the most. Nonagon is 9. Decagon is 10. So deca, just like decade. Hendecagon is 11. And dudecagon is 12. Now really, I would say almost from 10 on, you may see people do like 13agon, or they may do 13gon. Either way, to tell you it's a 13-sided figure. So you're going to see a mixture of uses, but I want you to know what to do if you get a specific named one. This one has that. Find the area of a regular decagon. So decagon on this list is 10-sided with a 12.3 inch apothem and 8-inch sides. So first of all, remember that we're using this formula. Now in this problem, they tell us that the apothem is 12.3. They tell us that the sides are 8 long. But if it's a decagon, I have to know that there are 10 sides that are 8 long. So our problem looks something like this. So if I go to plug that in my calculator, 0.5 times 12.3 times 8 times 10, I end up with 492. And because these are inches, this is going to be inches squared. Now, this one had no picture at all. If it helps you to draw a picture, you're welcome to do that. I think a lot of people have problems if it's 10-sided. If you're trying to do that, just try to do 10 points maybe that are equally spread apart. 1, 2. So here is, let's see, 1, 2, 3, 4, 5, 6, 7, 8. And if you can go through and do that, you can connect your points. It might be a lot easier for you. Some people really struggle with the doing the points thing, so that might be helpful for you. Okay, now this is where the majority of our issue becomes. Find the area of this regular pentagon with 7.2 feet long sides and a 6.1 radius. So I have the radius but no apothem here. So I'm going to have to find that. Well, that wasn't a very good A there. Sorry, being OCD, you know how I am. Okay, so first of all, if I'm going to do area is 1/2 the apothem times the perimeter. If this is 7.2, I know that every single one of these sides is that. So the perimeter part is 5 times 7.2. Because there are 5 sides that are 7.2 long. The issue for me is going to be the apothem. So one of the techniques that we use in this section, in this section is really to break this up into these triangles. When this apothem drops, it splits this in half. So if that's 7.2 for the whole thing, that means that both of these pieces have to be 3.6. So if I were going to take that off and just look at that triangle, then I would know that this side's the apothem, this is 6.1, and this side is going to be 3.6. So more than one way of choosing how to solve this. Most people would probably use Pythagorean Theorem. That tends to be what they're the most comfortable with. So a squared plus 3.6 squared equals 6.1 squared. Now, if we're looking at this, it's probably easier to actually take those and multiply them out, those squareds. So a squared plus 3.6 squared is 12.96. 6.1 squared is 37.21. Okay, so now subtract 12.96 from both sides. Which gives me 24.25. And then to find A, I have to do the square root of that. Now if I'm going to round this to the nearest tenth, it's probably the easiest to use, which makes that 4.9. Because it's like 4.9244 keeps going. That means back up here, I now know this is 4.9. So area is 1/2 times 4.9 times 5 times 7.2. So 0.5 times 4.9 times 5.72 gives me 88.2, and this is going to be feet squared. Now remember on this, you really have to be careful about rounding your numbers early on, like this 4.9. That could change how this looks. So keep that in mind. Now one more piece we need to look at. There's an idea in this section that's talked about the central angle. Sometimes it's helpful to know what the central angle is. Now, if I go all the way around this, first of all, a central angle is an angle that's created in the center by radii, or by the radiuses. So this right here, this would be a radius, and this would, so this would be an angle. And all of these would have to be the same. So if I were trying to figure this out, first of all the way around would be 360. There are 6 triangles that are there that are all the same, which means that it would be 60 degrees. That means that each of these would have a 60-degree angle all the way around. And that's going to be an idea that we are going to use later on.